Namaskar, I am Dan Gowde, Assistant Professor in Mathematics Center for Distance Education, Shivaji University, Kolhapur. Today I will discuss the differential equations. First topic, linear differential equation with constant coefficient from MSc1 semester first. Definition of linear differential equation with linear equation with constant coefficient. A linear differential equation of order n with constant coefficient is an equation of the form a naught y raised to n plus a1 y raised to n minus 1 plus a2 y raised to n minus 2 plus dot 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 plus a n y is equal to b of x, where a naught is not equal to 0, a1 a2 dot a n are the complex constant and b is the complex valued functions on an interval I, where a less than x less than b. The operator L defined by L of phi of x equal to phi raised to n of x plus a1 phi raised to n of n minus 1 of x plus a2 pi raised to n minus 2 of x plus dot 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 plus an pi of x is called as the differential operator of order n with the constant coefficient. The equation L of y is equal to b of x is called a non-homogeneous equation. If b of x is equal to 0 for all x in I, the corresponding equation L of y is equal to 0 is called a homogeneous equation. Now, initial value problem for second order differential equation. We are concerned with the equation L of y is equal to y double dash plus a1 y dash plus a2 y is equal to 0, where a1 and a2 are constant. Theorems now see here. Let a1 and a2 be the constant and consider the equation L of y is equal to y double dash plus a1 y dash plus a2 y is equal to 0 if r1 r2 are distinct roots of the coefficient characteristic polynomial p of r is equal to r square plus a1r plus a2. Then prove that the function of phi1 of x is equal to e raised to r1x and phi2 of x is equal to e raised to r2 of x are the solution of L of y is equal to 0. If r1 is the repeated roots, then if r1 is the repeated root of the characteristic polynomial p of r, then the function phi1 of x is equal to e raised to r1x and phi2 of x is equal to x into e raised to r1 of x are solution of L of y is equal to 0. Proof, let phi of x is equal to e raised to rx be a solution of L of y is equal to 0. Therefore, L of e raised to rx is equal to e raised to rx double dash plus a1 e raised to rs dash plus e2 e raised to rx and is nothing but r square plus a1 r plus a2 e raised to rx. L of e raised to rx is equal to 0 if and only p of r is equal to r square plus a1 r plus a2 is equal to 0. If r1 and r2 are distinct, then L of e raised to r1 x is equal to e raised to L of e raised to r2 of x is equal to 0. Therefore, phi1 of x is equal to e raised to r1x and phi2 of x is equal to e raised to r2x are the solution of L of y is equal to 0. If r1 is the repeated roots of p of r, then p of r is equal to r minus r1 square and p dash of r is equal to 2 into r minus r1. L of e raised to rx is equal to p of r e raised to rx for all r and x. Dou by dou r of L of e raised to rx is equal to dou by dou r of p of r e raised to rx. L of x into e raised to rx is equal to p dash of r plus x into p of r e raised to rx at r is equal to r1, p of r1 is equal to p dash of r1 is equal to 0. Therefore, L of x into e raised to r1x is equal to 0, and showing that x into e raised to rnx is the solution of L of y is equal to 0. Thus, if r1 is repeated to roots of characteristic polynomial p of r, then phi 1 of x is equal to e raised to r1x, and phi 2 of x is equal to x into e raised to r1 of x, r1x, are solution of L of y is equal to 0. Next theorem, if phi 1 and phi 2 are two solutions of L of y is equal to 0, then c1 phi 1 plus c2 phi 2 is also solutions of L of y is equal to 0, where c1 and c2 are any two constant. For proof, suppose that phi 1 and phi 2 be two solutions of L of y is equal to 0. L of phi 1 is equal to phi 1 double dash plus a1 phi 1 dash plus a2 phi 1 is equal to 0. L of phi 2 is equal to phi 2 double dash plus a1 phi 2 dash plus a2 phi 1 is equal to 0. Suppose c1 and c2 are any two constant, then the function phi defined by phi is equal to c1 phi 1 plus c2 phi 2 is also solution of L of y is equal to 0. L of phi is equal to a phi 1 plus c1 phi 1 plus c2 phi 2 double dash plus a phi 1 plus c2 phi 2 plus a2 a phi 1 plus c2 phi 2, and we get c1 L of phi 1 plus c2 L of phi 2, and L of phi 1 is equal to 0, L of phi 2 is equal to 0 is equal to 0. This is the phi which is 0 for all x, is also a solution called the trivial solutions of L of y is equal to 0. The results of above two theorems allows to solve all homogeneous linear differential equations with constant coefficient